Algebra 1, Common Core, Unit 4, Section 3, Literal Equations. So this is coming after we're just solving equations, and literal equations are essentially equations where we don't have a lot of numbers and we have more letters. But we have to remember that when we're solving equations, the process didn't really change a whole lot, whether it was decimals or fractions or whole numbers. And so if you have an equation like 2x minus 1 equals 3, how is that different than ax minus c equals d? Well, in the first step of the 2x minus 1 equals 3, you would add 1, right? You add 1 to both sides. Well, in the ax minus c equals d, we're going to add c to both sides. See, if we're trying to solve for x, first of all, you got to know what variable you're solving for. In this case, we're solving for x and all these down here. But in solving for x, I'm trying to get it alone. When it comes to 2x minus 1 equals 3, it's on the left side of the equation. Now, what else is on the left side of the equation? I got a times 2 and a minus 1 attached to it. Well, we add and subtract things away first, so I got to add that 1 away first. And it's the same thing over here. I'm going to get this x alone, and it's times an a and minus a c. So I'm going to add or subtract things away that I can first. My result over here is going to give me 2x equals 4. My result over here is going to give me ax equals, now d plus c, they're not like terms because they're not the same letter, so I can only write it as d plus c. 3 plus 1, we know we can make 4, but d plus c is just d plus c. All right, it doesn't become dc because that would imply multiplication. They're adding, so d plus c is d plus c. In the regular equation here, the next step was, because they're being multiplied, we do the inverse operation of divide 2. Divide 2, divide 2. Well, here, this is a times x. So we're going to do the inverse of multiplication to get rid of that and divide a. Divide a. Now, over here, we get x equals 2 because 4 divided by 2 is 2. But here, again, because it's all letters and there's not really like terms that you could work with, you're going to end up with d plus c over a. And that's the answer for a literal equation. That's what it looks like. It's basically moving things around to isolate a variable. And that's what we've been doing this whole time. We just have more letters now. So this example that's typed out for you in this box here is from a 3a squared minus b equals c example. And the first step, again, was add or subtract things away. Because what we're solving for in this case is a. So to first add b to the other side makes it then c plus b. And then, 3a squared, you got to deal with the 3 before the exponent, so we divide 3 on both sides. And then the last step, if you have an x squared, we haven't seen a whole lot of this, but, if you had a simple equation of, where can I find a little bit of space to work with over here? X squared equals 25. I think we know the answer of 5, but how do we get that? Well, we know that, we undo subtraction with addition. That's the inverse operation, and vice versa. We undo multiplication with division, and vice versa. Well, what about square? What's the inverse operation when something is squared? And the answer is you square root. Right? Square and square root are, opposite sides of the same road, right? They're the inverse operations, and that'll give us x equals. But when you square root something, it could be positive or negative. And so you get plus or minus 5, we call it. Really, that means you get two answers. You get a positive 5 and a negative 5. Because if you think about it, we know that 5 squared is 25, but also negative 5 squared is also positive 25 because of the whole negative times negative thing. So that's why you see when we square root both sides here, we put that little plus minus symbol in front. So you might see that in a couple of examples here. All right, try a couple of problems down here. Now, again, we're solving for x in each of these. So first, find x. Here it is on this first one. Let me zoom in for you. So to get that x alone, it's on the right side. So I'm just going to leave it on the right side and move other things away. I have a times n and times m and a plus b. So I'm going to minus the b first. Minus the b. And again, I can't really do much with this y minus b except write it as y minus b equals m times x. And just like we do always when we have a coefficient, these are being multiplied, so the way I could get rid of that m is through division. So divide m. And the final answer here is y minus b over m equals x. That's it. X is now alone. Doesn't matter, it's on the right. You could reverse this whole thing if you want. Write it as x equals y minus b over m. All right, let me zoom out a little bit to move over to these other problems here. That sliding bar kind of disappears on the bottom of my screen for some reason. All right, so here we want to, again, solve for x. You know, where is x? Here it is. There's only one x in the problem, so I don't need to worry about that, at least not yet. Again, you have a 2 times it in the front and a plus c after it. So the first step is going to be minus c. Now, on the left, that'll cancel out and we just have the 2x. But on the right, notice that, you know, when I did y minus b, I couldn't combine them, but there is a c term over here. So I can combine those like terms. So that 5c minus c becomes 4c. And plus d still just plus d. And then the last thing here again is get rid of that coefficient. I'm going to divide. So divide. So the final answer here is x equals 4c plus d divided by 2. That's it. All right, unfortunately, I think I'm going to have to zoom out even more now to be able to see this last problem over here. And again, we're solving for x. It's on the left side. First, I want to, anything I could add or subtract away. This a squared is being added to it. It's positive, so I will subtract a squared, so minus a squared. And that's going to leave me with x squared on the left and c squared minus a squared on the right. Then what we saw up in this example here, that when I have a squared, I need to do the square root. So I'm going to square root both sides because I don't want x squared, I want just x. And that leaves me with an answer of the square root. But don't forget, we got to do a little plus or minus there. And that's something you'll learn more about when we get into quadratics and completing the square and things like that. But this plus or minus the square root of c squared minus a squared. And that's actually the answer. Sometimes people think the square root of c squared minus a squared should equal c minus a, like they could do the square root of the things inside. But the minus sign kind of ruins that. So this is not a true thing. You know, I could give you an example there that if you had, say, like the square root of 9 minus 4. Well, that's really sloppy. Let me rewrite that. Let me do it over here. I got more space on the left here. So the square root of 9 minus 4. Does that equal 3 minus 2? Well, you could just do the square root of 9 minus 4, right? Like you can simplify inside here. We could always combine like terms. Square root of 9 minus 4 is the square root of 5. Is that the same thing as 3 minus 2, which is 1? No, it doesn't work that way. And it has to do with the subtraction sign in there. Because squaring and square rooting are kind of, you know, forms of multiplication. And, you know, we can't undo multiplication with subtraction. And, you know, they're not pairs. They're not inverse operations. So that kind of ruins it. It's very similar to how, you know, if you have 10x divided by 2, you can make it 5x. But if you have 10 plus x divided by 2, you can't divide both these things by 2, so it kind of just stays that. I mean, you could separate them to each be over 2, and then, but, you know, again, a topic for another day. So in this case, the answer stays plus or minus the square root of c squared minus a squared. So literal equations are really just solving equations like we were doing this whole time, just like this, except instead of adding 1 and dividing 2, you might be adding c and dividing a, and that type of stuff. All right, that's it for literal equations. See ya.